Hi everyone, my name is Nathan and I'm going to be giving a tutorial on how to do an unsupervised classification in QGIS. I'm going to cover everything from data acquisition to getting the output ready for analysis, as well as calculating some basic statistics. What I'm showing you here is just an example of a product showing what you can do with an unsupervised classification. It's clearly not a polished map, but it does give a visual representation of the land classes in that area. Anyway, let's get into it. So first things first, when it comes to doing a classification, is we need to acquire some data. For this tutorial, I'm using data provided by the USGS Earth Explorer. Now, you have to have an account, but you can create an account for free, and it's a really good resource, so I would recommend creating that account. First thing we're going to do is we're going to select which data set. So for the sake of this tutorial, I'm using Landsat 8. You can use pretty much any multispectral or aerial photography for this, but Landsat 8 is very common, so I am just going to use that. So I'm going to select Landsat collection level 2, collection 2 level 1, and Landsat 8. Next, we're going to add some additional criteria. I know exactly which file I want. So I've got the product identifier in here already. And I'm going to include this so you can just copy and paste it. And then I'm going to hit results, and it should bring it up fairly quickly. Here it is. So I'm going to hit footprint, and that'll show you where it is. So as you can see, this is up in northern Canada in the Northwest Passage. And to download this data, I'm just going to go over here for the download options, and I'm going to want product options, and I'm going to want to download the entire collection 2 level 1 product bundle. As you can see, it is a rather large file, and this is zipped, so once it's downloaded, you have to unzip it, and I will walk you through that process as well. So for now, I'm just going to hit download. It's going to ask me where I want to save it. This looks good, final report, and then I'll save it here. As you can see, it's going to take a while for me, so I'm going to pause the video and we'll be back when it's done. Alrighty, so as you can see, it is now done downloading, and it is in a .tar format. So that is a type of zipped file. Windows doesn't have a built-in feature to extract tar files, so you need to download 7-zip. You can easily access it. Just Google 7-zip. You're going to go to 7zip.org and select the download for your machine. I imagine a lot of people are running 64-bit Windows machines. So this is the one I downloaded. Anyway, so then you're just going to go back to the file, right-click. You go 7-zip. You're going to extract files. I like to do extract here, so it won't create another file. It'll just extract it into the file it's already in. So extract here. And there you go, it's all there. So what you can do now is you can go ahead and delete this tar file, and that'll just free up a whole gigabyte of space. Not a bad thing to do. So I'm going to delete that. And now the next thing you need to do is bring all this data into QGIS. All right, so now we have to bring all that information into QGIS. So to do that, I am just going to build a virtual raster. So you go to raster, miscellaneous, build virtual raster. We got to select our input layers, and that is everything that we extracted from the tar file. I don't want to do it one at a time, so I'm just going to do add directory since I know where all the files are saved. And they're saved in this directory here, so I'm going to select folder, and that's going to bring up everything. We don't need everything though, so I'm just going to deselect what we don't need. So what I've left here are just the different bands from that file. So what I mean by that is each band represents a different wavelength. So for instance, band 2 is the blue wavelength, band 3 is green, and band 4 is red. But since Landsat 8 uses a multispectral sensor, it's more than just, the bands that you and I can see. It also includes things like near infrared. So that would be band 5, or thermal infrared like band 11. If you're interested in all the different bands, here I can just pull this up real quick. And we can look at the different wavelengths. And this is everything included from band 1 to 11. And as you can see, there are some different resolutions, but that's all right. That's why when we bring in the files, we're just going to do highest so that there's no resampling. So I'm going to hit OK. And I'm just going to do resolution highest, as I said. We don't want any resampling. And we're going to place each input file into a separate band. We're bringing them in as separate bands, and we kind of want them to stay as separate bands. We don't need to worry about projection difference. This is all taken from the same source. And we're just going to save this as a temporary file. We can change that later, but we'll start with a temporary. So I'm just going to hit run. As you can see, that brought in all the bands. So I'm going to close this. And we get a rather interesting looking representation of what we were going for. And that's just because this is a false color composite. So as you can see, band 1 has been assigned red, band 2 green, band 3 blue. And as we know, that's not quite right because band 1 is coastal aerosol. So we actually want to assign this to be a natural color composite just so that it's something we're more used to. And yeah, so we'll start off to make the red band red. So the red is band 4, the green is band 3, and we're going to set the blue to band 2. When I hit apply, okay, as you can see, this is looking much more natural. So we've got lots of islands, lots of ice, and lots of water. And this is what we are going to run our unsupervised classification on. So we could do the classification over the entire Landsat image, but that might take a while. For instance, on my fairly powerful machine in 2021, it took a little less than an hour to classify the whole region. So we might as well also learn how to do some clipping of rasters because if, for instance, if you have study sites and you just want to do a buffer around those study sites and classify the region there, we could do that. So first things first is I got to sort of drop a point anywhere here. So we're going to just make a layer, create layer, new shapefile layer. Geometry type is going to be point. And I've already done this, so I'm not going to do it again. But what I did is I just placed a point on this island here. And then I created a buffer around it. So to create a buffer, you go to Vector, Geoprocessing Tools, Buffer. Input layer is just going to be your point. Distance is going to be the radius of the buffer. So I set mine to 10 kilometers. Currently, it's set to unknown units because we don't have an input layer. But I'm just going to bring in the buffer. So here it is. That is the region I'm buffering. And now I'm just going to clip that. Clip the raster to this region. To do that, I'm going to go to raster, going to go to extraction, and as you can see, there are a few clipping options. So you've got clip by extent, so you can just set an extent, or mask layer. I'm going to choose mask layer, and what this will do, it'll clip the raster to that buffer. So the input layer is going to be our virtual layer, the mask layer is going to be our buffer, and I believe the rest is good to go. So I'm just going to hit run, and then close. And as you can see, we now have a clipped region. We can now finally get to the part where we actually classify this clipped region. So in order to do the classification, in this case, we're going to download a new tool called SCP. So the way you get a SCP tool, you go to Plugins, Manage and Install. And then you just search it up. So as you can see, I've already had a search here. So like SCP, there you go, brings it up again. And then you're going to select this. You're going to install it. I don't have to. I've already got it. So I'm just going to make sure that box is checked. All right. And that gives me access to this tool. And this tool has all sorts of options. But first, we need to set the band set. So we open that up. And we're going to set our band set to not the virtual layer, because that is the entire Landsat 8 image, but just the clipped one. All right. So once we've got that, it brings up this list down here of all the bands. You can see we've got 11 bands. And then it's been brought in. So the next step is to do our band processing. So we're going to go to clustering here, and we have an input. We're going to use the k-means method rather than ISO data because we kind of have a good feel about how many classes there are, or clusters in this case. And we're just going to set that to 5. The reason why I'm setting it to 5 is because I know I have at least 3 land, water, ice. But then also, this tool in particular, it just does a white box around the region as well. So there's my 4th, but I am also including a 5th in case maybe there's a different type of ice that we want to classify. So looking in here, we've got that really, this is a late summer image from the Arctic. So this is when there's the least ice. And as you can see, there's some really soft ice. It's kind of brown. And then we also got that more vibrant white. So we're just going to start with 5 classes, and we're going to leave the maximum number of iterations at 10. So an iteration is just how many times it'll go through the process trying to refine the clustering and the classes. So we're going to use random seed signatures and a minimum distance algorithm because this k-means really goes off of neighboring pixels and their values to try to determine what value the pixel in question has. So we're just going to run that. And it'll take a bit. Oh, first you got to save it. So I've got one already, but I'm just going to replace it with the exact same name. So now it's running it, and it'll take a few minutes. So we'll just wait till it's done. So the classification is finished, and as you can see, I did end up with 5 classes. I've got the water, land, I've got 2 different types of ice, and I've got this weird box all around it, which isn't relevant to the classification. That's just the nature of the SCP tool. And as you can see, I've ended up with a lot of water on the island, and I don't think there was that much in the first place. So there is a little, I believe there's some water here, and there's a bit more around there, but it did end up kind of speckly. So that is likely just some noise. Luckily, there is a way to filter that out. So using the same tool, I'm just going to open it up again. There is a post-processing option. I'm going to go in here, and I'm going to select sieve. And I'm just going to use the mask class, which is the one I've got. I'm going to set the threshold to 25 pixels. So what that means is the minimum size of a cluster is going to be 25 pixels. So I'm not going to get any single pixel clusters like that. It's going to be 25, and I'm going to set the pixel connection to 8. 8 meaning that pixels on the diagonal are also considered touching pixels. So I'm just going to hit run. We're going to save it as a mask class filter. I had one here, but I'm just going to replace it. Makes a little noise when it's done. And as you can see, it got rid of that one, and it's just left these bigger clusters. So that kind of just smooths out the image. And as we can see, there's a whole lot less noise in there. And now we're ready for our next step, which is vectorization. You could stop here and just create a map using this output raster, but it is a lot easier to calculate statistics when you convert the raster into a vector. For instance, you can get things like area or edge length and stuff like that. So I'm just going to convert this raster into a vector using a built-in tool. So I'll just get rid of that to clean it up a bit. I'm going to go to raster, conversions, polygonize. So this will change each one of those clusters into its own little polygon. So I'll click on that. I already got the correct raster selected. Everything looks good. So I'm just going to hit run. It'll just take a minute here. Great. I'll close that. And as you can see, it all ended up kind of one color. So we can fix that though. I'm just going to click on this. Instead of single symbol, I'm going to do categorized. And then I'm going to classify based off not FID, but DN. FID is just the unique identifier for each polygon. DN is the value it previously had in the raster, like 1, 2, 3, 4, or 5. So DN, classify, there we go, 5 classes. Okay. As you can see, got my 2 types ice, got my water, got my land, and I've got the strange border. Let's check out the attribute table. So here's that DN, and DN tells us what type of land use it is. So from this, we can actually calculate a new field, and that field is going to be the text string representation. So like the English name for that land cover. So I'm just going to click on Field Calculator, create a new field. Field name is going to be land cover. It's going to be a text string, and I've already got the code written out for this. So I'm just going to paste that in there. Ooh, got an extra word. All right, let's make sure this is right. So you need the case, and then when DN is 1, then land. Let's see, is that correct? Yeah, so it looks like the land is in fact that color. How about 2? When DN is 2, then bound. Yeah, so that's the color of the outside. When DN is 4, then ice. So let's see, 4. Ooh, let's change that to water. And then else is going to be ice. So that's going to be 5 and 3, it looks like. So let's hit OK. And there we go. We've got the outside here. And now we can do further processing with this. So for instance, I want to get rid of all of the bounds. The way I'm going to do that is fairly simple. All I'm going to do is click on this land cover. And there you go. That brings all the bounds to the top. Looks like we got 37 different polygons. And all I'm going to do is highlight all 37 rows. Oh, that's too many. Here, we'll start at 37. We'll go up. That makes it a little easier. And then I'm just going to simply hit this delete button. There you go. That got rid of all the bounds. If I go turn off this layer underneath, that leaves the circle behind. That's not the last thing I want to do though. So we're going to go back to the attribute table. We've got 3 open apparently. Go back to the attribute table here, and we're going to add a new field. And this field's a little different. I just want to know the area of each of these polygons. I have nothing in mind particularly when it comes to further statistical analysis, but area is a pretty common one. You can get this from Raster 2 using a pixel count, and we know the size of the pixel, so you can just do some basic math and figure out the area of each one. But I want to calculate it this way. So we're going to create a new field. Field name is going to be area. Not going to be a whole number. It's going to end up being a decimal. And then what we're going to do is we're simply going to calculate the new column. So all I'm going to do here is go to, where is it? Geometry. Gonna hit area. And then all I'm going to do is hit OK. That's all I need to get area. And there you go. It gives me the area of all these polygons. And if I want, I can export this into a CSV, and I can bring it into R and do some processing there, or I can do processing Excel. And it just really opens up what you can do with this raster once it's a polygon. And my favorite part about having a raster turned into polygons is that I can go in and I can change things. So it's really hard changing individual pixels in a raster. There probably is a way to do it. I don't know how to do it, especially when it's just so much easier to just transform them into polygons. So let's go here and let's just change something. So I don't think there was water like this on this side of the island. I could check. Let's have a look. And this is just kind of part of that post-classification analysis, if you will. So I'll turn this off. I'm like, yeah, there's no water there. Let's fix that manually. So I can go in and I can select this one. You know what, for argument's sake, let's select a few of them. So I'm just gonna hit Control on my keyboard. I'm gonna select a few. There you go, just like that. Awesome. And I'm just gonna open up that attribute table again. I left it open. And I can't see where they are, so I'm just going to go to Show Selected Features. And here I can change everything in the same way that I calculated the land cover already. So I'll just go into Open Field Calculator. We're going to only update selected features. I don't want to create a new field, update existing field. Let's start with DN. So that's land. And land, I believe, was 1. So what we're going to simply do is go here. We're going to select our field and values. We're going to go to DN. And then we're just going to do DN. These ones are 4. So I'm just going to write -3. And that should just bring us down to 1 on all of them. So I'll hit OK. There we go. DN's 1. That doesn't change our land cover type here. So what I'm going to do again is I can open up that field calculator, update existing field. This time we're going to update our land cover. And since I already have the whole thing typed out, we've used it already, I'm just going to use the exact same thing that we used earlier and paste that in there. And obviously it's a little redundant, but it's easy to copy and paste, so might as well. So I'll just hit OK. There we go. They all got updated to land. So I can hit save. That saves the edits. I'll turn off editing, close it, and then I'm going to deselect those ones. There we go. As we can see, they are now land class. So that's pretty cool. Can do that editing. And up here, if we want, we can make this a little more user-friendly. 1, 2, 3, 4, 5 doesn't really mean a whole lot. So we can, well, sorry, not open attribute table. Click on that, go to symbology. Instead of using DN, we can use land cover. Apply. Oh, got to update this. So classify. There we go. Got our 3 classifications. Apply. Okay. As you can see, it got rid of the 2 different types of ice. If we wanted to, we could have kept that. But just for the sake of this tutorial, I'm just leaving it as the 1 type of ice. I'm no ice expert, so we're just going to leave it as the 1 type of ice. In order to clean this up a bit, or at least clean up how it looks, what we can do is we can merge some of these polygons together. So we ended up with whatever it was, 5,000 something. We can merge some of these. You don't have to, but we can just experiment with that. So you got to select the polygons you want to merge. I just selected a random chunk of the ice ones. We're going to toggle on editing, and then you're going to make sure that your digitizing toolbar is activated, and so is your advanced digitizing toolbar. So I just deactivated it, sorry. There you go. And you're just going to go here. So this one says merge selected features. It'll ask you some questions. And then you're just going to hit OK. So hit OK. And there you go. As you can see, it got rid of a whole bunch of the different ice ones there. We can try that again. So let's just go here. We'll take a few more, or a bunch more, I guess. And if we want, we can also do this through the attribute table, like selecting these. And we'll just select a few more, and we'll do it again. And we'll just go merge. There we go. It's taken a while. I selected a lot of features, I guess. There we go. Okay. And it merged even more of them. Here, let's try one more time. We will open up the attribute table for this. And we're just going to select land cover. So we got all these ice ones. You know what, let's merge a whole bunch of them. So I'm just gonna grab all the ice, just like that. You know what, 400 is probably enough. I'll minimize that. I'll hit merge again. And this one might take a while. So once this one is merged, what we're going to do is we're just going to go create a basic map. We're not going to mess around with any of the statistics that we could. So we're not going to do any calculations like that. That's really up to your application. But it is nice just to display the data to sort of show that you've got some kind of final product. I imagine everyone's already done this, but I could just go through a quick demonstration just to see how it goes. So first thing I'm going to do is just change the color on some of these, because this truly is kind of difficult on the eyes. I'll make it a little bit of an off-white for the ice. Land, you know what, it can stay green. We'll change the water to blue though. There we go. Okay, that's looking a little better. So next step I'm going to do is I'm actually going to make a map. So to make a map, we're just going to go to Project, New Print Layout. Let's call it Map. Okay. And we got to bring in what we just created. So we're going to go to Add Item, Add Map, drag just like that. It should render it. That background's a little distracting on the Landsat imagery there. So I'm just going to go here, turn that off, go back to the map. And this should auto update. Yeah, just like that. The scaling's a little wrong, so let's fix that. Let's zoom it out a bit. So I'm just going to change this to see if that's good. Yeah, that's pretty decent. Slide that around. We're going to use this so we can move just this part. Bring it over here. Got to add a few items to actually officially make it a map. So we'll start with a scale bar. Just like that. 5 kilometers, that seems about right. That's about half the radius that we were going for. Let's add a few more things. So let's do a north arrow. Here we go. Just add it in this corner. And then what else do we need? Guess we should probably add a legend. We'll just drag that in here. Now, clearly this is showing absolutely everything, and I do not want that. So what we're going to do only show items inside linked map. And that should be much better. There we go. All right. Let's add a little title to our legend. And we pretty much have a map. And all that we're missing is a title for our map. So let's add a title, add label, put that there. I'm going to type in, what should we call this? Classification. This isn't a great title, but it's a title, so we'll stick with that. And we'll increase our size. Probably want like a 36 maybe. Sure. There we go. This map isn't good, but checks all the boxes of a map. We have the content here, north arrow, scale bar, and a title. That's all I have for you today. We did everything from the data acquisition to actually coming up with a final product. And we even calculated some fields that you could use for some statistics later on, depending on what your application is. Hopefully this is helpful to you, and good luck with your classifications.